everyone, welcome to the lesson number 8 of our module. We will study mass spectroscopy, which is a continuation of the spectroscopic techniques from the lesson number 7. Mass spectroscopy is a very beautiful method. It is used to determine the molecular weight of compounds. This method is extensively used, and we also have some upgraded versions of this technique. So let us start the video and see what mass spectroscopy is. Lesson number 8, Mass Spectrometry in Pharmaceutical Analysis. So dear students, in this lesson we will study a different kind of technique. This technique is known as mass spectrometry. In the previous video I have told you the difference between spectroscopy versus spectrometry. So then what is the difference between spectroscopy and spectrometry? The main difference is that in spectroscopy our sample remains intact. When we perform the spectroscopy, the sample is not degraded, it is not broken down, it remains intact. Whereas in spectrometry, the method is invasive and the sample is actually defragmented into ions, and this sample does not remain intact. There is a degradation of the sample. That is why it is known as spectrometry. It's an invasive kind of procedure. So mass spectrometry is an extremely powerful analytical technique. It gives us the direct result. It is very widely used in pharmaceutical analysis, particularly where research is going on. This method is used for detecting the molecular mass, or you can say that molar mass of the sample. The molecular weight of the sample can be identified, of the organic compound can be identified. So in this lesson we will study into the mass spectrometry and we will explore its application in the pharmaceutical field. So the principle involved, first, this is ionization. So in ionization what we do is we first convert the molecule into ion. Let us say that in our sample we are having a sample, and in sample we are having a particular organic compound. What we will first do, that this organic compound is in the unionized form, we will first convert into ionized form. Particularly we are interested in positive charged ions. So ionization can be done by electron impact. There will be a beam of electron that will be bombarded onto the sample and it will convert the molecules into ions. Now the second method is acceleration. In this method the ions are accelerated in the electric field. There will be electric field in which the ions are accelerated, they will be moved. Now after moving, these ions are passed through the magnetic field, and in the magnetic field, as you know that moving charges can also produce magnetic field. The magnetic field will deflect these ions and they will separate them on the basis of their mass to charge ratio. I will show everything in the next slide. But first you must understand what are the steps. First is ionization, second is acceleration, third is deflection, and fourth is detection. Now in detection these ion currents are measured. The ion will be the ion which has been separated will collide onto the detector. The detector will detect the mass to charge ratio and it will tell us the mass of the compound. Now let us see these steps. Now as I have told you, what are the steps? First steps was the ionization. In this ionization step what we do is that we introduce the sample from here in this mass spectrometer. This is a particular diagram of it, and there is an electron beam source. It will throw the electron beam onto the sample and the sample will get ionized. Now second thing was, in the previous slide, second thing was acceleration. So first of all, sample was introduced and the sample was ionized by bombarding a beam of electron to the sample. This is how ionization was done. Second thing was acceleration. Acceleration means we are increasing the speed of the particle. So these two are the electrodes, and obviously they are generating electric field. One is minus, one is plus, and this electric field attracts the ion towards itself, and these ions are accelerated with a speed. So that's how ions are accelerated by the help of electric field. Now these charges then move and they are passed through a magnetic field. This magnetic field performs the next step, which is known as deflection. Now this magnetic field will deflect the ions, and ions will, the beam of the ion, see, this beam contains ion A, ion B, ion C. Ion B is having, A is having different mass to charge ratio, B is having different mass to charge ratio, and C is having different mass to charge ratio. So these ions are separated on the basis of mass to charge, and these get separated through the effect of magnetic field. Why magnetic field separates these ions? It is because these ions are moving, and from the basic concept of physics we know that moving charges will produce magnetic field, and the magnetic field produced by the charge interacts with the magnetic field produced by the magnet. These two will interact, and due to this interaction a force will arise, and this force will deflect the charges of the particle. The force depends upon the mass as well as the charge of the particle. So due to the mass to charge ratio, these particles are deflected. Now after deflection, the last step is detection. These deflected particles, they strike onto the detector surface, the detector detect them, and a mass to charge information is given, and by that way we check the mass of the compound. Here is the diagram. This is the photograph of a typical mass spectrophotometer. Now, how many types of mass spectrometry are there? There are three types of mainly mass spectroscopy. This is a electron impact ionization, electron spray ionization, and matrix assisted laser desorption and ionization. You just have to know their names. These are important techniques. Electron impact ionization is the most basic kind of mass spectrometry, and the matrix laser assisted desorption and ionization, which is MALDI, is a very latest, a very important techniques. This technique is used for the identification of protein. See, the protein is a very complex molecule, and a very sensitive molecule. The study of the molecule, the protein, the mass, molecular weight of this protein cannot be easily studied by electron impact ionization. We need some softer techniques, so that is how MALDI is used. So MALDI is more sophisticated technique which is used basically for the protein analysis in the proteomics. Now, what are the applications of mass spectrometry? So, they can be used to identify the drug metabolites. See, mass spectrometry has only one thing, one information to give. It tells us about the molecular mass of the substance. It tells us about the molecular mass of the substance, and it also tells us about the relative abundance. So by the help of mass spectrometry, sorry, we are identifying the different drug molecules, metabolites, chemical compounds. They can help to, this method can help to identify and characterize these metabolites. Second is quantification of pharmaceutical. So can also be used for the determination of drug concentration in the complex mixture, and this method can also be used for the structural elucidation of the unknown compound. You can easily know the molecular weight of the unknown compound. Now this is a typical graph of a normal mass spectrometer, mass spectrum of a organic compound. Here we can see the graph of ethanol, CH3 CH2OH. The molecular weight of ethanol is 46, and this is how mass spectrometer fragments the molecule into different parts, different fragments, and each the weight of each part has been taken. And now you can see this, the 46 is there, the peak, this 46 shows the molecular weight of our compound. This is basically called the molecular ion peak. It will tell us the molecular weight of our sample. So that needs a different level of expertise to understand the mass spectrum. Now, the application of mass spectroscopy in proteomics. So in proteomics, it can be used for the protein identification. Like as I have already told you that it is used to identify and characterize protein. And I have already told you about MALDI. Okay, MALDI is used, and now it is also used in post translational modification analysis. You have modified the protein and now you're detecting the modifications that you have done. Okay, now it is also used in metabolomics and lipidomics. So metabolite profiling, for metabolite profiling we are using MS, mass spectrometry, and we are just checking the metabolites of the sample, and we are profiling small molecules in the biological sample. It is also used for the lipid identification as well. So it is very crucial for identifying and quantifying the different lipid molecules. Now, what are the challenges and advances for the mass spectrometry? See, the challenges are that the sample complexity. So if the sample is very complex, it will be difficult to identify the mass spectrograph or a clear mass spectrum of the sample. The compound has to be pure, because there will be a lot of fragments generated in the graph. As you can see, for a simple molecule of ethanol, there are, you know, this much graphs, this much peaks. So if a molecule is very complex and if it is containing a lot of compounds in the sample, so it will become very difficult for us to understand or to study the mass spectrum of these graphs. So sample complexity plays a very crucial role. Now the sensitivity, obviously if you are performing the trace level analysis, you expect that your mass instrument is very sensitive. So sensitivity issues can also happen. If you are performing trace level analysis, you need to be extremely careful while performing mass spectrometry. Now what are the advances? There are high resolution mass spectroscopy now obtained. There are tandem mass spectroscopy, which is called as MSMS, that is used for the to improve the specificity. Now let us summarize our chapter. So the chapter first introduced the mass spectrometry. It's a very versatile technique. It can be used for both qualitative analysis and quantitative analysis of pharmaceutical compounds. Obviously, this method is used for detecting the molar mass of that compound. You can easily understand it by judging the molecular ion peak. The principles involve ionization, acceleration, deflection, and detection. In that, you understood that the molecule is first ionized, then it is accelerated through the edges of electric field, and then you deflect it by using a magnetic field, and then you detect it by mass to charge ratio. Now what are the applications? You have also studied the applications of this compound. It can be used for the drug identification. It can used in metabolic studies. You are studying metabolites, different metabolites. You are studying in proteomics. You are also studying in the lipidomics. There are advanced techniques. You have heard the names like HRMS, MSMS, and these methods will enhance the capability of mass spectrometry in the pharmaceutical research. Thank you. So, dear students, I hope you have understood the mass spectroscopy. This was all about the basic introduction of mass. There is many more to it, but it is sufficient for the beginner undergraduate student to understand the what mass spectroscopy is. So now on the next video, we will be studying about the validation and quality control. So till then, take care of yourself and keep practicing. Thank you.